Hello students, welcome back. Let's have a look at the next question, which is a board question from the year 2024, and it's a 3-mark question. The question is, state Fleming's left-hand rule. Apply this rule to determine the direction of force experienced by a straight current carrying conductor AB placed in a uniform magnetic field as shown. What will happen to an electron which enters the same field in the same direction in which the current is flowing in the conductor AB? Give reason to justify your answer. Alright, so first let's know what's Fleming's left-hand rule. It states that if we stretch the forefinger, middle finger and the thumb of our left hand in such a way that they are mutually perpendicular to each other, then if the forefinger represents the direction of magnetic field, the middle finger represents the direction of current, then the direction in which the thumb points represents the direction of force acting on the conductor. That is, if we stretch the forefinger, this is the forefinger, this is the middle finger and this is the thumb of our left hand. So if the three fingers are stretched out mutually perpendicular to each other, that is, each of the three are perpendicular to each other. So the angle between the thumb and the forefinger is 90 degree. The angle between the forefinger and the middle finger is 90 degree. And the angle between the thumb and the middle finger is 90 degree. So in this case we say that they are mutually perpendicular to each other. So if the three fingers of our left hand are stretched in such a way, then if the forefinger represents the magnetic field and if the middle finger represents the direction of current flow, that is the direction in which the current is flowing. So the current which we are talking about here is the conventional current that flows from the positive terminal to the negative terminal, and not the electronic current which is due to the flow of the electrons, that is flowing from the negative terminal to positive terminal. So the middle finger represents the direction of flow of the conventional current. Then the direction in which the thumb points, it represents the direction in which the force will act on the conductor, or the direction of motion of the conductor. So this is Fleming's left-hand rule. Now in this question we are asked to apply this rule to determine the direction of force experienced by a straight current carrying conductor AB which is placed in a uniform magnetic field. So we have a magnetic field which is going from left to right in this direction, that is towards the right. Then the electric current, that is due to the flow of the positive charges, it is going in the upward direction. So this is the direction of current. Now we need to find out, using Fleming's left-hand rule, in which way the conductor will be deflected or it will be pushed. Now let us align our fingers which are stretched mutually perpendicular to each other so that it satisfies this diagram. Now let us understand this question through this diagram. So here you can see the magnetic field is going from left to right. So we have aligned our forefinger which represents the magnetic field, it's pointing to the right. So the magnetic field B is to the right. Now the electric current which is represented by the direction of the positive charges, it is pointing upwards because the current is going upwards. So here it is represented by the middle finger which points upwards, representing the direction of current. Now you can see the direction in which the thumb is pointing, it is inside. Alright, so it is inside. So we see that the direction of force acting on this current carrying conductor AB will be inwards, or it will be into the page. Alright, so this will be the direction of motion of the conductor, or the force acting on the conductor, that is into the page. So the answer to this question will be force on the current carrying conductor will be inwards or into the page. This is the first bit. Let's solve the second bit question. Now in the second part it's asking us what will happen to an electron. Now electron we know is a negatively charged particle which enters the same field in the same direction in which the current is flowing in the conductor AB. It's saying that the electron is going in the same direction as the electric current. So in this way, here instead of electric current, in this direction the electron is going. Okay, so this is the direction of motion of the electron. Now, as I have said you earlier, the current which we are considering in case of Fleming's left hand rule is the conventional current, which is due to the flow of the positive charges and not the negative charges. So in which direction the positive charges will flow, we will point our middle finger in that direction. And we know that electronic current is opposite in direction to the conventional current, that is, in which direction the electron will move, the conventional current moves in exactly its opposite direction. Now, if the electron is going in this direction, that is from B to A, then the direction of conventional current would be downwards, opposite to the direction in which the electron is moving. Now, electron is going from bottom to top. So, the current will flow from top to bottom. So, this should be the direction of conventional current. Realigning our fingers so as to satisfy this condition, we see that the magnetic field is towards the right. Now, since the electron is moving upward, conventional current or the current is going downwards. So, I have pointed my middle finger downwards, representing the direction of the conventional current. Now, we see that the direction in which our thumb is pointing is outwards. That is, it's pointing towards us or it's pointing out of the page, right? So, we see that in this case, the direction of motion of the conductor will be outside the page or outwards. So, here the motion is outwards. So, now let's write down this answer. So, we can write it as the electron is moving upwards, so the current is going downwards. Realigning our fingers as per Fleming's left hand rule, we see that the thumb point outwards or out of the page. So, the conductor AB will be pushed outwards or out of the page. So, this is the solution to this question. So, with that we come to the end of this video. If this video was helpful to you, please do give it a big thumbs up, like it, share it and subscribe to the channel. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.